I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and posting brilliant questions. Here is a question from our IB student in Europe. Now, my YouTube channel makes sense even after 10 years. It is mathematics after all. If it talks sense, it matters. I hope you find this example extremely useful. Feel free to write your comments and suggestions. So, this question is taken from Sequences and Series. I've rated this as a tips question which can make a lot of difference in your marks. In case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. The question here is: studies indicate that in a lake, the number of fish will decrease by 7% each year unless new fish are added. At the end of each year, 250 new fish are added to the lake. At start of 2000, there are 2500 fish in the lake. Find the approximate number of fish at the start of 2025. So that's the question for you. Looks simple, but there is a common mistake which most students are doing, and because of that, I've taken this particular video. You can always pause, answer the question, and then look into my suggestions. Now, it is best to make a table of values so that we see how the population of fish is changing. So let's begin with what is given to us. So here is a small table. So let's say we talk about year and the number of fish. Year given to us starting is 2000 and we have 2500 fish. Now what happens in 2001? That is what we should think about. So the population decreases by 7%. That's key, right? Decreases by 7%. Second, at the end, we are adding 250 new fish, right? So we are adding 250 new fish. So these are the two things which are going to happen. So existing population of 2500 decreases by 7%. Now if I say 7% means 1 minus 0.07, correct? So that becomes the population, means 0.93, right? And then at the end of 2000, we added 250 fish, so they are also existing, correct? Perfect. Now, this factor, which is 1.1 minus 0.07, we could write this as 0.93, right? So let me just show you here. So what I'm going to do is replace 1 minus 0.07 to 0.93, correct? Same thing. Right. So let's see what happens in 2002. Now, this is where you have to be very careful. What really happens is that this number, 2500, which already existed, reduced to times 0.93 and further by 7%, right? Perfect. On the other hand, the 250 which were introduced will also be reduced by 0.93 and then we are also adding 250. Does that make sense to you? Now, the key here is that you need to reduce the added fish to 250 also by 7%, right? They are part of population at this stage. So that is kind of key. Now, you do think about series and figure it out, right? So what happens in 2003? Well, clearly in 2003, the fish which were added earlier, they will reduce further by 7%. And so we could write this as 2500, we have to multiply by 0.93 power of 3. Do you see that? So in 2003, we get 2500 into 0.93 to the power of 3. And here, you see the series, we have 25 250 times 0.93 that further reduces by 7% plus 250 times 0.93, right, plus 250. Makes sense. So that is how the population is going to change with every year. Perfect. Now it is simple, and you can now write down the value for 2025 and get the answer. Perfect. So, what do you think will be the population? Can you write this in a short form? And then we can apply the sequences and series formulae to get the answer, right? Okay. So, well, 2025 will be 2500 times 0.93 to the power of 25, right? That is how the power is moving. You can correlate. And on this side, you see the first term is 1 less than 3. So we have 250 times 0.93 to the power of 24, right? Plus 250 times 0.93 to the power of 23 plus so on till last year you added 250. You get the idea. So that becomes your series which you should be added and find the answer. Perfect. So I hope till now everything is absolutely clear. I would like you to take out your calculators, calculate the values, and then check with my solution. So let's use the formulae which are known to us, right? So let me take this on a new page now. So we are saying in 2025, situation is that we started with 22,500 fish, and that should be multiplied by less 7%, 0.93 to the power of 25, plus we have 250. And if I take 250 common, let's see. If I take 250 common, right, then what do I get? Well, I get 0.93 to the power of 24, 23, and so on. Correct? So that is how, and the last term will be 1, right? So, so 20, and then I get 0.93 to the power of 24 plus 0.93 to the power of 23 plus so on till 1, right? Look here. So it is the last term is not being multiplied by 0.93, right? So it is 0.93 to the power of 0. So that becomes another series. Perfect. Now with these two, you can get the answer. So that should total to what? Let's use calculator to calculate. 2500 into 0.93 to the power of 25 plus apply the geometric series formula to write down this number, right? 250, and here we have 0.93 to the power of 24 minus 1 over 0.93 minus 1, correct? To get the net result. Perfect. So use your calculator to find the total number, right? So that is how you should be calculating the number of fish in 2025. Perfect. So I hope you find this interesting and useful. What I did here is typed out the solution for you, as you can see, right? So have a good look at this particular solution. So we started with the initial population of 2,500 each year, 7% reduction, right? So that is how you get this exponent, right? In 25 years, that will be 2500 into 0.93 to the power of 25. And the added 250 fish will also go through the same decay factor, right? So, but there will be one power less. Perfect, as you can clearly see. So that forms a geometric series which we calculated. And once you calculate approximately, the answer is 3353. So that becomes the population of the fish in 2025. I hope that makes sense. Feel free to write your comments and suggestions. If you like and subscribe to my videos, that'd be great. Most important, share your questions and get perfect answers. Thanks and all the best.